Asteroid Belt. You have probably heard about asteroids. They are relatively small celestial bodies that move in a solar orbit and are significantly smaller than planets and satellites. These objects were full of mysteries until the beginning of the 19th century, when the asteroid belt was discovered by astronomers. The history of the study of small bodies in the solar system was largely influenced by the formulation of the Titius-Bode law in 1766. According to this theory, there should have been an object between Mars and Jupiter, at a distance of 2.8 astronomical units from the Sun, that is not inferior in size to the other planets of the solar system. The first object that resembled these assumptions was accidentally discovered by an Italian astronomer named Giuseppe Piazzi on the night of January 1, 1801. Piazzi observed a small dot of light moving against the background stars, and follow-up observations confirmed that it was not a star. This new celestial body was named Ceres, after the Roman goddess of the harvest and patroness of Sicily. For many years, Ceres was classified as an asteroid, but today we know it as the smallest of the dwarf planets in the solar system. However, Ceres was only the first object discovered among the many that were hidden in the asteroid belt. After the discovery of Ceres, data from other similar objects began to reach astronomers. 15 months later, on March 28, 1802, Heinrich Olbers discovered the second major asteroid, Pallas. In 1807, two more asteroids, Juno and Vesta, were discovered. The search for asteroids resumed after the Napoleonic War, and in 1830, data about the new asteroid Hygiea was brought in. As telescopes improved, the rate of discovery of small bodies in the solar system continued to grow. By the middle of 1868, their number had exceeded 100. A new stage in the study of asteroids began in 1891 with the use of Max Wolf's methods of astrophotography. The method involved taking photographs with long exposure periods, which resulted in asteroids leaving short light trails while the stars remained stationary. Max Wolf alone was able to discover 248,000 asteroids by October 1921, 10,000 by 1981, and by the year 2000, the number of discovered asteroids exceeded 100,000. In 2017, the database contained 739,062 asteroids recorded in the solar system, of which half had their orbits accurately determined and were given an official number. According to current estimates, there may be 1 to 2 million asteroids measuring more than 1 kilometer, and most of the known asteroids are concentrated within the asteroid belt. The asteroid belt contains a much larger number of celestial bodies than are currently known. However, since modern search systems for new asteroids allow for complete automatic identification, most scientists do not actively search for them. Instead, asteroids are often referred to as cosmic debris left over from the formation of the solar system. Researchers focus their attention on asteroids that could potentially pose a hazard to Earth. But where did such an unusual region come from? Today, most theories suggest that the asteroid belt is not made up of exploded fragments of once-forming planets but rather an accumulation of protoplanetary matter. The significant differences in the chemical composition of asteroids exclude the possibility of their origin from a single body. It is more likely that the asteroid belt is the remnant of a planet that failed to form due to the gravitational influence of Jupiter. It is believed that gravitational disturbances caused by Jupiter's presence caused most of the material in the asteroid belt to disperse during the first 2 million years since its formation, leaving less than 10% of the original mass. Some asteroids from the belt may have been preserved in the Kuiper belt or among the icy bodies of the Oort cloud, but a significant portion is likely to have been ejected from the solar system. The total mass of all the bodies in the asteroid belt is only 4% of the mass of the Moon, and a large portion of it is concentrated in the four largest and most famous objects: Ceres, Pallas, Juno, and Vesta. In many images of the belt, it is depicted as a dense area with millions of small dots. However, the objects in the belt are actually located at such large distances from each other that spacecraft passing through the belt have never collided with any of its inhabitants. The average diameter of the four most massive belt objects is over 400 kilometers, with Ceres being the largest. The majority of other asteroids in the belt are significantly smaller. The composition of the belt is a result of its formation near Jupiter. Jupiter's gravitational field constantly disrupted the orbits of the objects inside the belt, causing them to fragment into numerous small pieces that were eventually thrown out of the solar system. In the main asteroid belt, there are three main spectral asteroid classes: carbon, silicate, and metallic. Carbonaceous, C-type asteroids are the most common objects in the belt, accounting for 75% of all asteroids. These objects have a slightly reddish tint and reflect very little sunlight, making them difficult to detect. It is likely that there are many more carbonaceous asteroids in the belt that have not yet been found due to their low brightness. The largest member of this class is the asteroid called Gaia. The next most prevalent spectral class is the silicate, S-type asteroids, which make up the interior of the belt. Spectral analysis of the belt has revealed the presence of various silicates and some metals, but almost no carbon compounds. The largest representative of this class is the asteroid Juno. Metallic, M-type asteroids, rich in nickel and iron, make up 10% of all asteroids in the belt. They are primarily located in the central regions and may be fragments of the metal cores of large planets that were disrupted in collisions. There are also some asteroids that do not belong to any specific class, but almost every three of them is part of a family. All these classes of asteroids hold significant interest in terms of space industry and industrial development. Asteroids are among the most accessible objects in the solar system, as landing and taking off from their surfaces require minimal fuel consumption due to their low gravity. They can also be valuable sources of resources such as iron, nickel, titanium, cobalt, platinum, and more. Many of the elements currently mined from the surface of our planet are believed to have originated from asteroids. These objects offer almost inexhaustible resources. For example, a small M-type asteroid with a diameter of 1 kilometer can contain up to 2 billion tons of iron-nickel ores, which is 2 or 3 times the average annual ore production. According to current forecasts, Earth could face a resource crisis in the near future, and asteroids may play a crucial role in helping to save our planet or, conversely, pose a threat that could wipe out all living things.